Good evening, everybody. It's Friday night, my friends. I hate to interrupt F-Zero music, but it is what it is, my friends. Welcome on in, everybody. Welcome. I am getting a much earlier start than normal here, friends, because I am super jazzed. I've had a breakthrough. Breakthrough? I've had some progress, some really cool progress, off camera today. So, with the game engine, just kind of, getting things together and working, and there's going to be there's a bunch of like back-end stuff to do tonight now. I'm hoping having a little extra time to work on it means I can, like, tonight, maybe we can get through the last 3 chapters, because last I looked at the differences between them, they weren't all that daunting. So we'll see, and there won't be anything visually different, or at least there shouldn't be. So but to catch you guys back up to speed, we were working on, see, I've already started looking at chapter 18. We're working on chapter 17 of this book that we've been using, this Vulkan book, to learn how to program stuff with LWJGL and Vulkan. And this was a biggie because it has to do with animations. And honestly, most of the changes here, there was a few things to change as far as the renderers and the engine stuff, and one additional shader file in order to support calculating stuff, but generally speaking, the biggest part of the code here had to do with just loading the data in from the model files itself. One big complaint I've had several times throughout reading this book is that while they do have the code there, they do show code changes when they change how a file is loaded into memory. It looks to me like there's still a few instances where they have hand-rolled some of the JSON files that they use, because doing just the changes that they had, particularly for this chapter, was not sufficient. Like, there's 2 files to load, and they don't really load both of them at the same time. They just load one, and I don't know if it wasn't working for me, but it could have been a different bug that I found as well, where I was just loading one file. But it seems to me like everything that I was looking at online seems to suggest that I had to load both, right? Because one is the mesh of the model, and the other one was all the different frames of animation. So long story short, I had to make a bunch of changes to how I load files so that I could load a separate animation file, and all this stuff is going to have to get reworked. Like, the actual loading of the data is good. It's just like how I load the files and how I find the files and all that stuff is all stuff that's just going to have to, like, I'm going to have to redo because it's pissing me off. I want to be able to do it in such a way that I can, like, pull things together and supply missing data when I need it. Like, for instance, a good example of that is, the early chapter when you're first doing texturing and you texture a rotating cube. The texture file for that is separate, as you would expect it to be, but there is no reference to that file inside the model file itself, which tells me that they hand modified the JSON file that they had that shows where to find textures, and I had to do something similar for it. So it's there's some things there I feel like they don't mention in this chapter either, like the two files and how they have to be loaded and what they contain and all that stuff. So it could be argued that that's kind of out of scope, but at the same time it's really not, because it's probably the most important thing is to be able to load up the file correctly and get all the stuff going. So I don't know, that's one part of this whole book that really needs a good overhaul. It's just like, show what commands you ran. That's one of the reasons why I don't like that they made it its own little program that you run separately to convert the models over to a JSON file and a binary file, because it muddies the lesson, right? It means that they've forgotten to say like how they ran it and how they and show it running and all that stuff. And so anyway, all that set aside, I did get it working, and I believe it is working correctly, from what I've seen here. I'm already over on the chapter 18 branch, but I haven't made any changes yet, so we'll be able to see exactly what's going on. So if I run this, and I will, let's just for sake of argument, I'll bring the game audio up here. I'll bring the music down for a second so we can hear the audio going too. Hopefully this works and doesn't cause me to be a liar. Oh, that's interesting. Oh, you know what? Hang on. That's why it's not working. 1 second here. Let's go and put that back in there. And that back in there. And oh, that's why. Never mind. You can remove that then. Still not coming through. I wonder why that is. That's weird. So there should be audio playing. Let me make sure it's actually playing. Yeah, it's definitely playing when I switch my thing over here, but it's not coming through the stream here for some reason. That's definitely not it. It should be happening like immediately too. Let's remove that. Oh, maybe that was what was throwing it off. That shouldn't have been a source. Oh. Well, that's not working. That's really weird. I mean, I don't use the audio on here enough, on this, much use it, on this partition enough to be able to test it. Let's close this for a second. I mean, it should happen immediately, these changes, but let's just make sure. Okay, yeah, no, it's definitely, I wonder why that is, muted. Like, I don't even see anything coming through on there. It's a little bit strange. Oh. That's why. That's why. That explains why this was working for me all the time. Okay, there we go. Now you can hear it. All right. That was not a program problem. that was a operating system setup problem. But cool. You can see the animation going, and per the chapter in the book, you can hit spacebar and pause it like that. Pause it pretty much anytime you want to. What I am finding interesting though, and I wonder if this is, yeah, something's up with my camera control where I can't go this way with the camera. I have to go around the horn here. I don't know what I did to make that happen, so I'm gonna have to fix that at some point. I must have something flipped or whatever. But I am noticing that, oops, I went way too far there. Uh-oh. Wait, did I? Huh. I used the WASD to move, and it zoomed me way far away there, it looks like. Wow, like super far away. Like it's going really fast. I wonder if well, regardless. I'm hoping that's not just a bug. I'm hoping I'm moving. It's just I'm moving way too fast. But you can see our dude here, and I'm noticing what I was noticing is that the his lantern is not actually making a shadow, which is interesting. I didn't even like his hand is making a shadow, but the lantern is not. And I could move the shadows around too, as you can see here. You can see it's casting different shadows and things, which is kind of nice. His sword is making a shadow, though. You can see as he moves around there that's doing it. But the lantern is not. I don't know if that's just... I get the feeling like that's maybe a model issue and not a shadow casting issue. But let's, just out of curiosity, let's run the book's code here. Let's close all these tabs out. What, I guess chapter 18 will be just as good. Yeah, chapter 18 will be just as good. Run that. Yeah, it's got the same issue. Okay, cool. So it's not a me issue. It's just, it must be just the way the model is coded or something, or maybe I don't know. Like, it's what's funny is the shadows do show up on the lantern itself, like as you move stuff around, right? They don't show up on the ground, so that's a thing. Anyway, it's neither here nor there. It's working the way that the book is working, as far as I can tell. So that's good. So we have animations now, which is nice. Hey, ZeroFX, welcome on in. So yeah, we appear to have to be animated, which is really nice. And a lot of what's coming up here is not like the rest of the chapters that are fleshed out don't really have anything to do visually. Like the visuals are going to stay the same. Hopefully, if I do everything right. They're more like optimizations and things. So that's what we're going to be working on now. And I think, like I said, I think based on the diffs that I've done for chapter 17, 18, and 18 and 19 and stuff, it seems like 18 has got a bunch of changes, but they're mostly removing stuff. Yes, progress has been made. It's mostly removing a lot of stuff as we change over to this buffer device address stuff. So that'll be interesting. And let's go and do that diff right now. 17 to 18 right here. There is a bunch of shader changes though, so that's going to be a thing. But it looks like it's the algorithms themselves stay the same. It's just the variable names themselves that are changing because they've changed like the references here. So hopefully it won't be too bad. Although they did remove a layout entirely, so I'll have to be on the lookout for all that stuff. But the other ones here are mostly, this one has has a different structure and stuff in it, also more extensions, and similar things there. What else? So yeah, most of this stuff is like changing some flags around, model cache, things like that. Render has a few little changes that I may not even need to make because of how I've done it. But the animation stuff does have a little bit, like a lot of stuff gets completely removed, which is fine by me. So we'll see how that all flushes out. Although they do add a push constants method in here and stuff. Or wait, did they move it? Oh, they just moved it. Or no? No, they created a push constants thing here, method. So that's a thing. Scene render. There's a couple constants changes I have to be very aware of because I tend to miss those when I'm doing the diffs, and that's what always gets me into trouble. The vertex buffer structure class just goes completely away, and shadow render, again, some constants changes, and a switch over to the empty vertex buffer structure for this stuff. And then we have to enable buffer device address in the device thing here, enable the feature. There's a new thing in the memory allocation stuff. The Vulkan buffer class gets a new property for address, and a getter and setter, it looks like, and a new property in a new method in Vulkan utils, which is actually a nice little small method, it looks like. So good things. So let's get the gist of what we're doing here. So buffer device address allows us to refer to buffer virtual addresses in shaders instead of using descriptor sets. This is very convenient to use a bindless approach where we will access data as pointers, and it will simplify the code a lot. The drawback is that any misuse in setting the addresses may cause the GPU to crash. See, that's a pretty big drawback, but okay. Basically, don't screw up your shaders or you're gonna have a bad time. Got it. First we need to enable the buffer device address feature in the device. And then scene render, vertex shader. This will help us understand how VDA works from the GPU side and changes that are required in Java code. We first use several extensions required to use buffer addresses and to use scalar layouts for them. The next part is quite similar to the ones used before. We just define output values and the uniforms we will use to store projection and view matrices. We do not define the structure of vertex input attributes. We will not need that. Vertices information will be passed to shader as a buffer reference, like a pointer. We can define the internal structure if that of that buffer as a GLS construct like this. Okay, so that's why we're defining the structure now, is because we're just passing the we're just passing in a pointer to the memory location for the vertex uniform somewhere here, and then we're defining it that way. Vertex buffer contains vertices data. Index buffer contains the indices to be drawn. And in the push constants, excuse me. In the push constants, in addition to the model matrix, we're passing the addresses of the vertices and indices buffers. Use a GL vertex index built-in variable. Okay. Changing the shader. The size of push constants has been changed. Right. We do not need now to define the structure of the vertices information when creating the pipeline. This is already defined in the vertex shader, although through the vertex struct. Therefore, we'll use the empty vertex buffer structure to model an empty placeholder. Therefore, the vertex buffer structure will no longer be required. Render entities method, which is now defined like this. There are no calls to VK command bind vertex buffers and bind index buffer functions. Drawing is triggered by calling command draw instead of calling command draw indexed. The set push constants needs also to be updated to pass the addresses of the buffers as push constants instead of relying on binding them. Okay. Shadow render changes. You update the shadow vertex shader. Shadow render. Animation render changes. Okay, we will pass the addresses of the following buffers as push constants. The buffer that will contain binding pose vertices. The buffer that stores weights information. The buffer that stores joint information. The buffer where we will dump the transform vertices. And this buffer is the one that will be used in the scene render stage. The size of the vertex buffer. You may have noticed that we first check if we're accessing indices above the size of the vertices buffer. This is very important when using BDA to prevent crashing the GPU by accessing illegal addresses. The rest of the code is quite similar. Instead of relying on storage buffers, we access them throughout the references. All these changes will simplify the animation render classes. We do not need to create descriptor sets for all the potential buffer combinations per animated model and animated frames. We will need to create a buffer for push constants and properly set the push constant size when creating the pipeline. Okay. So basically, because we push a lot of information in order to do the animation, like every frame of the animation and all the different way the body parts are supposed to move and all that stuff. And now this is saying, like, we don't need to set all that stuff up ahead of time. We can just kind of dump it into a buffer and just tell the shaders, here's your buffer, go to town. Like, here's where all the data is in memory. Have fun with it. So that's kind of nice. All the buffers that are passed as references need to be created with the VMA allocation crate dedicated memory bit flag. This affects the model's cache class. So that's good. Your face is kind of nice. Thanks. Your face. In your face. These changes also affect the animation's cache class. Okay. Alright, so let's at the gist of it. So first thing I'm going to do, since we're removing our text buffer structure, let's just nix that right away here, if I can find it. Where is that? Text buffer structure. Okay, where are you? Oh, you're literally right there on the screen. Okay. All right. Goodbye to you. Yeah. I didn't do the usage search, but that's fine. I probably should have, so it removes the imports for it, but screw it. Okay, so that's gone. So now the next thing we probably should do is the changes to device. So let's go device. We're at chapter 18, somewhere around here. There we go. Nice. And that is called, well, it's called local logical device for me, but also I believe it's the thing that we're changing is in a utility. Yeah, create device info. All right, so what did they change here? Features 1, 2. var features 1, 2. Buffer device address. And then scalar block layout true. All right, so we're doing for device address true. And then features, so after depth clamp, features shader int 64. Here it is here. Okay. Features. And then, is that everything? So that's everything to device. And then mem alloc. Did I call that this too? Memory. I think that's what I call memory allocation util. Yeah, it is. Okay. For create VMA allocation create info calloc. Allocate create info calloc. Here we go. What was it called? Flags VMA allocator create buffer device address bit. Okay, so this guy. VMA allocator create info. So flags create buffer device address bit. Yeah. That's everything that changed there. Vulkan buffer. We have an address now. Okay. Vulkan buffer. So we get private long address. And then where did I change this at? So in the constructor underneath memalloc pointer 1 buffer usage. Oh, that whole thing is brand new, huh? Memalloc pointer 1. Okay, so right under here, we're saying if buffer usage has the VK13 VK buffer usage shader device address bit set. And then this address is Vulkan utils get buffer address buffer. We'll have to do that utility next. But we'll keep that broken for the moment. And then in cleanup, or not cleanup, they just have a get address. If address is null, throw a new illegal state exception. Okay. So we're going to have get address here. So what I will do, yeah, I guess I'll put it here. Let's say getter on address, but then I will put the check in there. If address is null, wait, when would address be? Oh, they made a capital L long. Okay, I was like, when's address going to be null? It was a lowercase long. Nope. Nope, it is not. Okay. So address is null, throw new illegal state exception. Buffer was not created with usage, but either device address bits. Alright, otherwise return address. Okay. And then, where's the utils at? Okay, utils. Let's do that right now. Oh wait, we have a new thing there, don't we? That's actually the next thing on the list anyway. Pointer size of 8. That goes under okay, constants. Short size. Public static final int. Pointer size is 8. So I have that, and then what was the other thing? So we have the new, this is the only other new thing is the get buffer address. Okay. Get buffer address. Buffer address, we'll need the device, so logical device, buffer, and stack push, no, just address is VK13 VK get buffer device address device get device and VK buffer device address info Pollock on the stack. This type default. Oops. This type default. Buffer of buffer. And then return address. I see why they defined outside of that. The problem I have there is, oh, never mind. It'll be fine. It'll be fine. I was gonna say it's never gonna return null, but it'll be all right. It will be all right. So get buffer address. So we just need the device there. Okay. So that is now a thing. And we're through this whole directory. So what else? It's mostly flag changes, so I'm going to kind of hold off on that for the moment. Animation render has probably the most changes. So let's do that right now. Renderer. Okay, so what am I changing here? We get push constants size. It's right there. Private static final int push constants size is Vulkan constants pointer size times 5. What else? We're creating a push constants buffer. Private final byte buffer push constants buffer. There we go. All right. And then it just comes in here into play here, right? Shader module and push constants size. Okay. Okay, so this dot push constants buffer equals memory util alloc push constant size, and then for here for push constant size push constant size. Right, so then the 0 we do this. All right. And then in cleanup, we have to free up that push constants buffer. Don't need this. Whoops. Don't need this in here because we're not using it. Which is interesting that that didn't cause a problem. Oh, here it is. Yeah, I was going to say. It caused a compilation problem. There we go. What else? So that was the cleanup, and then in load models, we get rid of the animation stuff. So model ID. So animated model. See, I've changed the way I've done it a little bit differently, but animated models. So we're still looping over the models, but yeah, so what I did was they check here, like if it has animations, then, or if it doesn't have animations, then continue. And I just do the check up front where I just say, just get me only the ones back that have animations. So I know that this list will only run for things that have animations. So then they're just doing, they're jumping right to the mesh. Right, so I don't need to do, where's model ID used? It's down there. So animation index, I should be able to get rid of all of this, right? That's what it looks like. That was creating the descriptor set, and then for the mesh, I get rid of the descriptor set stuff for the weights and for the vertexes. So vertex size, group size map, put, and then that's it. Huh? Okay. So just get rid of that. Get rid of that. And then for the entities, it looks like I basically get rid of that entire thing. The loop for entities altogether. Because all that's doing is creating a descriptor set. So yeah, because this just ends after group size map. Okay. So animated entities, all that goes away. Okay. Good. So that means I don't need, there's a lot of stuff I don't use now. I don't need device. They've only got model cache there coming in, so I don't need device. I don't need the allocator. I don't need the list of entities. I don't need the animation cache anymore, so yep. Works for me. Less is more in my book. Alright. Then for render, passing the animation cache into render. Okay. We're getting rid of the descriptor sets and descriptor allocator. Let's see. Let's see. Render, where's render at? So fence weight reset, memory barrier, command handle command bind pipeline, and then so command handle. So what did I get rid of? So descriptor sets, descriptor allocator. Which for me is just descriptor sets, right? Yeah, descriptor allocator, just pulling out that big honkin' thing that they have. So I just get rid of descriptor sets. Get rid of the descriptor allocator here. And they're looping over the entities. And again, they do the check to see if there's any, just for the animate entities. So I just pull out the animate entities first, which it doesn't mean I'm doing a loop twice, obviously, but that's fine. So animate entities. So they're doing. So it looks like they got rid of the whole loop there. So prior to the meshes loop, they're adding, prior to the meshes loop, they're adding animation, the get animation list and joint buffer address. So that would be these two. They're looking over. So I got model here. Yeah, they got model and then they're looping over the meshes. And so I got model and I'm looping over the meshes. So right before they loop over the meshes, they do Vulkan animation. Where did entity animation come from? Oh, I can just do E. Entity animation. Animation index. And then form joints buffer address. Animation frame buffers get e dot get entity animation get current frame get address. Okay, and then so looping over the mesh, they're just doing set push constants. And then command dispatch. So let me just check over here. Yeah, I got rid of the descriptor sets, and then this got reduced down to just the call to set push constants. And then the command dispatch dispatch stayed the same. Yeah, the descriptor sets goes away. All right. Okay, so get rid of that. I don't know if I need the ID still. Let's keep that for a second. And we gotta call. Yeah, I don't think I need ID, but let's see here. Net push constants. Command handle. Mesh. Vertex buffer, get address, mesh, weights buffer, get address, joints buffer address, animation cache. Let's put that up here. Animation cache get buffer e dot get ID mesh ID get oops get address and then mesh vertex buffer get requested size divided by Vulkan constants float size. Okay, we have to make that class or method, but that's fine. Okay, so ID just goes away. It's fine by me. Just make a little space there just so I can see it. Hand handle, group size, map, ID, 1 and 1, 1 and 1. And then recording stop. It looks like the rest of the method is the same. Yeah, and then they just added the set push constants. Okay. So we'll get to that. Private void, set push constants, vk command buffer, source buffer address, wait, buffer address, joints, buffer, address, destination, address, source, buffer, float size. Okay. So offset 0, and then we're increasing the offset by pointer size. Okay, so offset 0, push constant buffer, puts long, offset source buffer address, offset plus equals constants, size. All right, we got source buffer address, weights buffer address, joints buffer address, destination address, and source buffer float size. All right, so weights buffer address, joints. Destination address. Source buffer, float size, and it's offset pointer size, offset pointer size, offset pointer size, offset pointer size, and then VK 15 VK. I can't see a damn thing. VK command push constants. So command handle. Pipeline gets layout ID VK13 VK shader stage compute bits offset 0 which constant buffer. Okay. And no compile errors. Good. Okay. I don't know how. I'll be honest with you. If you're just reading through the book, like just through the text of the book, I don't know how you'd be able to parse out the changes that they're actually telling you to try to do. Like you basically have to bring their code down and then just compare the last chapter to the current chapter. Just to see all this stuff, because there's so many things that I found just doing these diffs here they don't even mention, and it's just like, man, come on, guys. Or they don't specify it in a way that like is easy to follow. Okay, so animation render class is done. These are more flag changes. Now scene render has significant changes. So I guess we'll do scene renderer next. For chapter 18. Alright, so push constant size changes. Okay, Outlaw. Eat up. So push constant size has changed to this scene renderer. There we go. Where are we at? Oh, did I put it somewhere else, didn't I? Well, let's see if that's the same. I have a push constants handler. When did I do that? I don't remember when I did that. I don't remember. I don't remember when I did this. Is this only... I think I only did this for scene render because I think because of the changes I made when I moved stuff around, I was like, screw this. Let's put this in a handler. And then I didn't use it on any of the other renderers because it didn't really need it there. That's fine. So matrix 4x4 size, and actually this might be closer to what I want to do in the future anyway. And then it's plus Vulkan constants pointer size times 2 plus the int size. Okay. So with that, what else did they change? So in create pipeline, oh yeah, instead of going to vertex buffer structure, they do the empty one now. So pipeline, create pipeline. So they do that. It pipeline, or did I call it create pipeline here? Create pipeline, all right. So this goes to empty vertex buffer structure. And then what else is there? Vertex PC size. Okay. Our vertex PC size is also constants, matrix 4x4 size plus other size times 2. Okay. And then push constant ranges are still there, but they have different sizes. So shader stage vertex bit offset 0, and then okay. Oh, so PC means push constant size. Okay. And then the same for this one. All right. Go. PC size is the offset, and then the int size comes after. Okay. And that's it there. And then down in render entities, we have some big changes here. Render entities. All right. Render entities. So what did they do? They are grabbing the scene, the list of entities from the scene. So they got rid of the try block, it looks like. One, two, three, four. 1, 2, 3, 4, 5. Yeah, they definitely got rid of the try block. And they got rid of the... Okay, I see. So they got rid of the try block, and they got rid of the vertex buffer and offsets. And scene moves up to the top here. Entities, get entities, entity size. Okay, number of entities. Okay, so let's do that first. So we'll... Wait, what? Oh, I was passing the memory stack in. Okay. I'm like, why don't I have the try catch in there? Because I just pass it in. So the vertex buffer and the offsets. go away, but oh, you know what? I moved those into bind meshes. That's why I'm confused here. Yeah. So I think most of my logic is in bind meshes. Yeah, here we go. So offsets in vertex buffer go away. Okay. And then we keep, so looping over to entities, grabbing the meshes. So looping over to meshes. So what else did they change here? So meshes, material ID, material, I think they're just calling these set push constants. Is that the only thing that's changed? Material, it's hard to really tell there. Let's see. Look at material. Mesh get material. Mesh does not have a thing, right? And then material is transparent. Buffer address is different. Okay. So material is transparent. I was doing this number rendered to see so I could trace that out. That's yeah. Buffer address is model has animations. Get buffer. Was okay. Oh, I have that here. So I have, if it has an animation, animation cache get buffer. Otherwise, that buffer. So it looks like they moved the push constants down below that. Right, and then get rid of this. Find those buffers. And VK command draw instead of draw indexed. That actually did change from draw indexed to draw. Okay. So do that. It's command handle mesh number of indices 1 0 0, and then get rid of this other 0. Okay. But this buffer oh, I see. Buffer address. So get buffer and ID, get address. otherwise mesh vertex buffer get address, and then set push constants goes command model matrix buffer address. Okay. So that'd be that. And then instead of material index, it'd be mesh index buffer get address. Okay, so their set push constants has changed. Oh, get address and then material index. So let me do that for a second. Material index is still there. It's just they added a mesh index buffer get address. So it's command model matrix buffer address index buffer address material index. And then, yeah, the set push constants has changed. So we'll go here. And we'll go here. So command handle, matrix 4F model matrix, long, so pipeline layout would be vertex, buffer address, int, or long, index buffer address, and then material index. All right, so then push constants. Okay, so what we got here? Vertex. You see, size is Vulkan constants. Matrix 4x4 size plus PTR size times 2. Okay, and then we're using the push constants buffer. Oh, right. I do this because I get an instance of it. Which did I add push constants buffer up here? No, I didn't. Okay. Well, it doesn't make sense being here. This is Vulkan model. Okay. Push constants buffer. So that's why we're doing that. That's fine. Get index 0. Put it into the buffer. Okay. Push constants buffer. So here's a change. So long int. Long int. Yeah, that stuff has changed. So let me just move these down a little bit so I don't get too confused. Push constants buffer, put long. Matrix 4x4 size, vertex, whoops. Buffer address. Push constants buffer, put long. Matrix 4x4 size plus Vulkan constants pointer size. buffer address. Johnson's buffer put int text size material index. There's one thing. Once we get done the rest of the chapters of this book, one of the things that is I'm going to have to try to figure out, and I understand the utility behind it, which is like we're trying to populate all these buffers, and so you have to get the offsets correct because they're, you know, it's like you want everything packed together and you want it to be consecutive. But what burns my ass a whole lot about this is this shit, right? And the offset plus equals blah 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 blah. Now I get it. It's straightforward. It's simple. It, you know, all this stuff. But I have got to, just for my own sanity, I have got to find a better way to do all that shit. if it's even possible, because the problem with stuff like this is that it's way too easy to mess it up. It's way too easy to calculate it wrong and not realize that you've calculated it wrong. And then suddenly you're getting all these weird and wacky and crazy outputs, or you're crashing and you have no idea why. You have no idea where to look. And it's just like that kind of shit just, it drives me nuts. And I get it. It's really compact. It's really straightforward and all this stuff, but it just, it's a maintenance nightmare. And there's got to be a better way to do this shit. I don't know what the better way is, but there's got to be a better way. I have to believe. I have to believe. So wait, we have vertex buffer address. Oh yeah, vertex index and then material. Okay, yeah, that's all three. All right, so then these other commands, so we can get rid of that, and then the push constants is command handle, and then pipeline. Yeah, no, pipeline layout ID is correct. Okay. Did I get rid of that for some reason? Did I get rid of the pipeline layout ID is up there? Yeah. Why did I remove that? I guess I removed it because I was confused for a moment. Oh no, I didn't need it in. Well, yeah, I did have it in here before. Huh. Let's just add it back in. Pipeline layout ID. Boy, this has got to be one of the most... Jesus, it's got to be one of the most annoying songs here. The Derelict Machine from Echo to Dolphin. Jesus, man. That's like driving me up a freaking wall. And we've got another 3 minutes of it. All right. So pipeline layout ID. So then we've got command pipeline layout ID, shader vertex bit offset 0, push constants buffer slice 0 to vertex push constant size, command push constants, pipeline layout ID, fragment bit, and then this is vertex push constant size slice from vertex push constant size int length. Okay. All right, so that's now changed. All right, and then that goes away, and then in the shadow renderer, we have a couple things here. More push constants stuff, which makes sense. So the push constant size changes. Push constant size, which I think I have just here. Yeah, push constant size is now 4x4 size plus PTR size times 2 plus int size. Okay. Please, for the love of God, this song needs to go. Jesus, 44 seconds left on it. I am sorry for that, friends. I don't have control over what actually plays. You guys do, though. You can go to rainwave.cc/OC remix, create an account, log in, and you can vote on what comes next. Ooh. Speaking of, am I logged in? Can I not vote on stuff? I am logged in, but it's not letting me, how do I get the voting things up? Because that was a... Oh well. Usually there's like a little vote button that shows up here, and I don't know how to, I don't know what I did to make that appear. I don't know what I did. Settings. I don't think power user mode is no. Definitely not. Definitely not. But there is a way to do it. I just not seeing it right now. Just not seeing it right now. Is there another that lost song title? Anyway, getting sidetracked. Sorry. That's what happens when you get like really annoying music. It just sidetracks the hell out of me. Okay, so done that, and then what's the next thing? Okay, we're gonna switch over to empty vertex. I know, right? It's like, and most of the time, like I listen to. Oh, Happy New Year to Beast Fighter there. I'm doing well. Sorry, I missed your chats over there. I apologize. It was like 20 minutes ago you chatted. Sorry. Happy New Year to you. Yeah, it's that's why I try, like, I like video game music because most of the time it doesn't have any any words or anything like that. And a lot of times it's like ambient music and things like that you know is pretty not chill's not the word I want to use, but you know, meant to be sort of background stuff, and so it doesn't really break your concentration that much. But occasionally some of these remixes are just it felt like they had a competition to make the most annoying thing they could. Yeah, white noise, exactly. All right, create pipeline. So create pipeline just is the empty vertex buffer structure. I have a knit pipeline. All right. Now that was like the only thing they changed there, right? Yeah. And then down methods is in the render. We're doing something similar, removing the vertex buffer and offsets. So render. Where did they remove those from? Right before the entities. Okay, right there. So these go away. Vertex buffer and offsets go away. All right. And so got the animation and vertex buffer. So it looks like it's basically the same thing. Animation vertex buffer address. All right. And then we get rid of this. And the bind buffers. And the bind index buffer. And we put a move set push constants below it. Change this to draw from draw indexed. And that last parameter. 100 is the same. Number of indices, blah, blah, blah. All right. And then for the set push constants, let me make sure I'm doing all this right. This is all the same change. Yeah, it looks like it. And then they change set push constants. Okay. Basically the same change as before, but just making sure that they didn't do something weird and strange here. So we have the model matrix. We have the buffer address, and then material index is the last one. Okay, so animation, vertex buffer address, mesh, index buffer, get address. Okay. So come down here. All right, so first and foremost, int vertex PC size is Vulkan constants matrix plus pointer size times 2 constants buffer. I'll move that down so I don't get confused here. So we got push constant buffer, puts long. Matrix 4x4 size. Oops, I gotta change this. Model matrix. Long vertex buffer address. Long index buffer address. Alright, and then this gets the vertex buffer address. Long 4x4 size plus pointer size index buffer address, and then push, oops, push constants buffer, put int text PC size, material index there. Get rid of the other one. And command push constants, command handle, pipeline, get LAN ID, vertex bits 0, and then push constant buffer, that stays the same. Okay. Any other surprises in here? No. Pretty straightforward. All right. We've done everything in this folder already. We did the scene renderer, the animation renderer. We did the shadow renderer too, right? Pretty sure I did that one. No, I don't think it. No, well, oh, we just did the shadow render. Duh. Like, yeah, so we just did that. I did that. And now I gotta do the caches here. Cache changes. So animations cache, models cache. These are flags. And then just some less stuff we have to pass to the render. Okay. So animations cache. Wait, is this the right chapter? No, it's not. Fuck you, IntelliJ. Why would it want to open up the chapter that has of all the same things that I already have open? Don't know. Excuse me, sir. It's cache A. I refuse to call it cache. It will and forever be cash. As in cash money. Oh. That's like SQL versus SQL. All that stuff. What was the other? Oh, Q. Some people, for some reason, treat the word Q like it's multiple syllables. Now, the one thing I have not heard actually pronounced, and I don't know if I've been pronouncing it correctly or not, is frustum, which is like the viewing frustum in a video game. So it's I guess I could probably see how it's pronounced, because I have no idea. I've never heard it used before. I've seen it written down, a lot, but I've never... Yeah. Frustum, the part of a solid such as a cone or pyramid between two parallel planes cutting the solid, especially the section between the base and the plane parallel to the base. So, out of curiosity, no, I don't want to mute the some of the best sound ever, Streets of Rage, but I gotta do it. 1 second here, because I gotta know how this sounds. Let's go.
Frustum.
Okay. It wasn't too far off. Uh-oh, we got Sonic the Hedgehog 2 coming on in. Alright. So, animations cache. Right. Open that up down here. So what changed? Load animations. Load animations. Looks like they added additional. Let's see. Load animations. So when they do the buffer. So buffer usage, vertex buffer bit, storage buffer bit, and then they added device address bit. Yeah, okay. Or VK13, VK buffer usage shader device address bit. I think that's the only change I made there, right? Yep, there. Model cache. Probably, yeah, all these are the same thing because we're creating. Although they changed the VMA memory usage auto. No, they didn't. Okay. It's just that it highlighted that one for some reason. Alright, so. Sounds Swedish. Yeah. Probably. Who knows at this point? Models cache. There we go. So where's this at? Is it the destination buffer? So just the destination buffers for crate indices. Oh, for all the crate weights and joints and vertices. Okay. So I'm gonna have to go because I don't have these all in the same thing here. Yeah, I moved all those to where I think they made more sense, which is under the model itself. Pretty sure. Yeah, I did. Okay, so I gotta go to Vulkan model. What is that? Messing up like that. Yes, all these crate methods. Mesh. Animations. So create vertex buffers. Create index. Create joints. Create vertex buffers. Create weights buffers. So all of those. Source buffer, destination buffer gets transfer storage index. What's this? Index buffers. Transfer text, storage or usage transfer. Destination bit, buffer usage, vertex buffer bit, storage buffer bits, and then buffer usage shader device address bit. Yeah, so just like adding all of that in there. Address bits, VMA, memory usage, auto, 0, 0. Okay. And then index buffers. Same thing, just on the destination. I just want to make sure. Buffer usage transfer, destination bit, index buffer bit. Yeah, okay. VK13, buffer usage shader device address bits. Memory usage auto. Oh, they do have a different change here. Oh, did they have a change on the other thing too? Allocation create. Wait a minute. Create vertex buffer. No, they still had 0, 0 in the vertex buffer. Okay. So they changed this too. See, it's a good thing I looked. So VMA flags here should be VMA allocation create dedicated memory bits. And then required flags is 0. Okay. That show up there. Does show up there. Yeah, and that does stay 0 on the vertex buffer. Yeah, it stays 0 there. So then the joints, maybe. Yeah, joint matrix buffers. Okay, so that still says stays 0, 0, and then it's transfer destination bit, storage buffer bit, and then the shader device address bit. Okay. Okay. Honestly, I hate to say it. It really pains me to say it. But one of the things I'm thinking about when I see all these flags and passing into buffers and stuff, this might be that one friggin' case where a builder pattern actually makes sense. And I hate to say it because I fucking hate builder patterns with a fucking passion. But when you've got like 9,000 different flags you gotta set, and for the most part, it's the same set of flags over and over and over again, it might lend itself to a builder pattern. That might be something I do in a refactoring here. Because, as I said, when I get done the book stuff, and I don't have to compare one chapter to the next, we're refactoring the hell out of this thing. Because yeah. Because yeah. And I just every pattern has a use. The only reason I don't like the builder pattern is because it's overused, I feel like. Everything has its use, but I feel like the builder pattern has become the sledgehammer, or has become the hammer, I guess, of the programming world, right? It's like, if all you have is a hammer, everything starts to look like a nail, kind of thing. And so they just keep injecting builder patterns into all kinds of absolute nonsense. And it bugs me more because I deal with Spring framework all the time, and the builder pattern fundamentally breaks the Spring framework, because the Spring framework is all about singletons and being able to inject beans around and not have to, just kind of take care of a lot of the boilerplate stuff. And yet the Spring freaking maintainers, I swear there's somebody on the Spring maintainers group that is just like, builder patterns everywhere, and they're just like putting builder patterns on every goddamn thing. And it breaks the usage of Spring. Like, the only way you can inject some things now is by using you can't use the XML injection stuff anymore for a lot of things. You have to use Java injection. And that's a big change. And a lot of times the Java configuration stuff, the configuration annotation and stuff like that, is 1,000% uglier a lot of times than just having an XML. And there's cases where having it in XML just plain makes sense. Like, hey, we have this thing that we don't really want the users to be able to configure because it's pretty complicated, but we may want to configure it on the server. We may want our support staff to be able to configure it on the server for an individual client, but our support staff aren't developers, right? So that it's not like they're going to write code and then deploy a new build. They want to just change it on a per customer basis with the same build that everybody has. So yeah, then it makes sense to be like, oh, here's the XML file, make that change, bounce the server, boom. It just works, right? It's like when you put all that into a Java configuration, yes, you can have, properties files and stuff, certainly. But, sometimes sometimes the changes are more than just like flipping a flag, What about having XML parsed to the necessary Java parts via custom implemented parser? Well, the whole idea is, for the Spring framework, the whole idea is that Spring is doing all the XML parsing, right? So you have an XML file that has your beans defined in it, and you just kind of let Spring do its thing. Right? Sure, you could do your own custom thing that's like, oh, I'm just going to go read this stuff in and all that stuff. But then, you've already got something available to you, right? So it's like, why not use the thing that's already available to you? But like I said, there's some maintainer on the Spring framework side who's like, builder pattern everywhere, and it's just and you can't. It's a lot of those things you can't inject via the old style Spring XML bindings, because it doesn't. You need setters and getters. You need properties to be able to set and you need POJOs essentially. And the builder pattern breaks POJOs unless they leave the setters around, or at least they leave them public instead of making them private, kind of thing. So yeah, but I mean that's my just giant rant about, you know, that's a bigger rant going on there. I mean, I generally like the Java at configuration Spring configuration stuff, because I think in some cases it is nicer because it's easier to find where you've created a bean, because you can just use your IDE to find it. You don't have to like look through a couple different XML files to find it. But it also means that if you want to change something, or you want something to be able to be changed from one client to the other, you got to find a different way to do it, you know? Oh, welcome back, Outlaw. Hope your dinner was good. I saw that you fixed your internet problem. That's good. Because I was thinking to myself, I wonder if like the cats got into the wiring and started, you know, chewing on things. But it was good that it was just just, you know, just became disconnected on its own. I haven't bothered myself much with module configuration and such. True. Yeah, and I mean, I'm also dealing with an application at work that is like 10 years old now, 11, 12 years old now. So yes, the Java annotation stuff, the Spring configuration, Java configuration stuff was around then, but it wasn't as there were still plenty of ways to find the old style XML configuration, and now it's like it feels like they're purging the documentation of any mention of the XML configuration around. Yeah, it was a random wire that got pulled when you're setting up and stay connected enough for you to stream for 17 minutes. There you go. I mean, that's always the case, right? It's like, it's just hanging on there and then it just pops out. And you're like, what the hell? I didn't change anything. It was just working. Always the case. Always the case. Oh, man. Well, I hope your day's been going well anyway. You know, despite the stress of running around trying to figure out what's on fire. Man, I know those nights. I just want to stream, damn it. Why is this not working? I know that all too well. All right, so that was the joint matrix stuff, and then index, joint matrix, vertex, and then the weights, the weight buffers. Weight buffers. It's this one, so then destination buffer is, okay, VMA flags is 0, require flags is 0. Buffer usage, transfer destination, vertex buffer, bits, storage buffer, bits, and then the shared device address bit. Okay. Okay. Good deal, good deal. All right, so that should be everything in this file. 1, 2, 3, 4. That's pretty much what I did. Okay. All right, so now into the render method itself, which I think is just going to be fixing compilation errors, right? Because we've removed some parameters that we don't need anymore. So render, there it is. And Vulkan renderer. Yeah, here we go. So all I need now is, I think, the model cache. Yep, that's all I need in here now. And I'm going to probably, the cache themselves, I'm probably going to make all of them singletons because it makes sense to me to just have the caches be singletons. The device I'm not sure about because I do use the Vulkan device a lot, and I don't think I'll have a need for having multiple device references because I'm making a game, not anything else. So, or game engine, not anything else. So I might be tempted to have like a get instance on that or something, or like a device device manager or something like that just has a reference to the device, because I know that they kind of just pass that around in a big glob of goo, so that would be one less thing to have to shuttle around all the time. Is that the only thing there? So animation model, animation render, load models in the init, and then animation. Oh, the call to render. File cache, animation cache. Let's see. It's in render. Oh yeah. So what do I do here? Device, scene and model cache. Okay. Oops. Yeah. All right. That's all the compilation errors taken care of on that. And then we just have a bunch of shaders that change. This is going to be a thing. All right. So the animation one. So I want the animation compute shader. All right, so extension, geo extension buffer reference required. Shader explicit arithmetic types int 64 enable. Okay. All right, and then I just basically have to make this look like the other thing here. So we're gonna just go straight through it. Okay, so all these go away basically. It looks like, even if they don't, I'm gonna get rid of them to main here, and then we'll just redo it. So layout standard 430. buffer reference, float buffer, float data, yeah, start 430. I'm assuming STD 430 is STD means standard, I imagine. I don't know. May not. May mean something completely different. I have no idea. Data. I just know. Killing me here. You could tell where they copied and where they didn't, because this is the Java way of doing it. This is the C way of doing it, and it's now annoying me that I have both here, but I'm going to keep it the same for now. All right. So layouts, local size X is 32. Just put them together like they have it. I know it doesn't matter, but it's a long line. Size Y is 1. Local size Z is 1. It's an in parameter. Layout push constant uniform C. And float buffer source buffer float buffer meets buffer matrices buffer joints buffer float buffer destination buffer uint 64t source buffer float size. This is our push constants. All right, void main base index.
I love the power glove. It's so bad.
Did they change the order of these, really? Just to be a pain in my ass. Okay. Or did they? Base index source buffer. Yeah, they did. Okay, so grab this. That up here. Source buffer. Location ID X times 14 if base index source buffer is greater than or equal to source buffer float size. Return, okay. Index weights buffer is X times 8. X vector 4 is okay. So PC dot
I love the power glove.
weights buffer data. Okay. So grab this. 'Cause all these are that. Honestly, you know what? I wonder if I could do... Can I do a refactoring here? Damn it. Nope. That was too much to hope for. And then it's the same thing on that one. And then the source vector. So PC source buffer. That source buffer. Okay. Position weights X. Yeah, all these change.
I love the power glove. It's so bad.
Joints X, Y, Z. Okay. That's not too bad. And then you see that destination buffer.
Yeah, well, just keep your power gloves up her, pal.
Points. Okay. This is PC joints buffer. Yeah. Next source buffer, and then this is PC source buffer. Alright, and then source buffer, PC destination buffer. And then back to source again. And back to destination again. Tangent, destination, yep. Actually, you know what? These are all copies, that's why. Let's do that. Let's do that, and then I can go grab the source buffer again. There we go. That should be everything, right? Looks like it. I think that's the gist of most of these changes in here. Yeah, PC joints buffer, destination buffer, source buffer. Okay. All right, and then the fragment shader doesn't have a whole lot that changed, so that's good. So fragment shader, where's that at? Under layout, push constants. Layout, push constant. Okay. So instead of 64, it's now 80. Alright, and then that's the only thing that changed, right? Cool. Vertex shader. Has new structures and stuff. Okay. There we go. Alright, and vertex shader. So we have some extensions here now. Buffer reference. Require. And GL. Buffer reference to enable. Scalar block layout require. Okay. So layout location 0. We just have outs and no ins. So layout location 0, out vector 4, out position 1, out vector 3, out normal, out vector 3, out tangent. Out vector 3, bitangent, and texture chords. Okay, so I get rid of all the ends. Okay. And then we've got projection uniform, matrix 4, matrix, view uniform, matrix view uniform. And then we've got. We do have the layout push constant, and then we got a couple other things. So we have uniform, and then we've got struct vertex vector 3 in position vector 3 in normal. 3 in tangent. Tangent. Up to vector 2 in texture coordinates. Okay, and then we got layout scalar buffer reference buffer vertex buffer vertex vertices layouts std 430 buffer reference buffer index buffer uint indices. All right, layout push constant uniform. You see normal matrix vertex buffer index buffer. Okay. So far, so good there. And then main. Okay, so we've got uint index is push constants, index buffer, indices, GL vertex index. Okay. Vertex buffer, vertex data is push constants, vertex buffer. Vertex data, vertices, index. Alright, and then vector 3 in position equals vertex in position. Position is push constants model matrix times vector 4 in position. There. GL position, projection uniform matrix times uniform matrix times world position. Okay. Matrix 3 normal. Transpose inverse matrix 3 push constants model matrix. Right. Out position is world position. Out normal. It's M normal times normalize vertex. Vertex dot in normal. Out tangent M normal times normalize vertex dot in tangent, and then in tangent. And then texture coordinates is vertex dot in texture coordinates. Okay. Okay, so that looks like we got everything there. And the shadow vertex shader. Alright, so we need extension, GL, extension, buffer, reference, require. Reference to enable. Scalar block layout require.
I can't remember anything without you.
That's very sweet, but try.
So we get, as usual, get rid of all the ends because those aren't mapped. So struct vertex. Coordinates. Okay. Position, normal tangent, bitangent, texture coordinates. Okay. Layout, scalar, buffer reference, buffer vertex, buffer. Vertices, layouts, STD430, buffer reference.
This guy, and she looks at me like she doesn't even know who I am.
It's indices. The hell is this? Oh, Disco Elysium. Okay. It's good. I'm like, it's a good song. I'm like, I've never heard this before. That's pretty good. Struct instance data for model matrix int material index int adding 3. Did we actually add padding in? Yeah, might have been calculated already into the thing. We'll find out. Push constants. Uniform. PC. Model matrix. Vertex. Buffer. Index. Buffer. And material index, push constants. Location 0, out vector 2, out texture coordinates. Location 1, out flat uint, material index. Alright, void main. So uint index equals push constants. Index buffer, indices, geo, vertex index. Vertex buffer. Vertex data is push constants. Vertex buffer. Vertex. Vertex data dot vertices index. Now texture coordinates would be vertex dot in texture coordinates. Now material index is push constants. Material index. Field position, push constants, model matrix times vertex in position LF. Alright. And that is all the shaders. I do believe we have covered the bases, so I guess let's just make sure it compiles. And indeed it does. Alright, well, let's see what happens. We should see just the scene that we were seeing before, so there shouldn't be any changes there, but let's see what it does. Yep, and we should still be... Oh, I still have the audio on too, so you can hear the music and audio. Our guy is still animating. You can still move the camera around. Okay. Alright, so far so good. That's chapter 18 done then. Alright, let's go commit that. So chapter 18 works. We change shaders, this, get rid of that, blah blah blah. Alright, push it. Cool. Right, let's close all of those out. And we go over to, let's close that out. Over to GitHub here. Chapter 18 at recent pushes. Chapter 18 changes. And 218 additions and 246 deletions. I'm a true programmer. Had more lines removed than added. Create pull requests. And squash and merge. Delete that branch. There it is. Okay, so that's all on the trunk now. I'm going to try from this point forward. I'm trying to maintain a stable trunk and do all the changes on branches so that I always have something to come back to, because as we're doing refactoring and stuff, it's going to be, and as we're doing new things, I'm probably going to jump around from topic to topic depending on what I'm in the mood for, and it'll be nice to just keep some of the in progress stuff on a branch and then just keep rebasing it as needed. And that's technically the proper way to do things anyway. So let's go to main here, and actually, you know what? Let's do it this other way. Let's do update and check out. Okay. And we'll move on to chapter 19, new branch. Go. Cool. And let's do chapter 19 here. We'll update this configuration so we're running the right thing to look at. Oh wow, chapter 19 doesn't show up there? I wonder why. Is there something wrong with their POM file? Huh. Well, that's weird. Yeah, the POM file must have a problem in it because it's not showing up as a Maven POM here. Validate. No errors found. Okay, well, why is it not showing up as a Maven POM? Huh. That's weird. Did I have something? They must have something misspelled or something here. Book 1.0, chapter 18. See, they added in chapter 18, they added Maven compiler source and target, and then I think that's gone again. I wonder if they removed the reference to it. Where the hell? They don't even have a thing here. Huh. I take it back. They don't even have a thing listed there. But they do have the parent POM. Maybe it's in the parent POM. We have Java version and source and target. Huh. Oh, that's why. They don't have it listed as a module. Well, that's weird. don't have it listed as a submodule. Maven sync. There we go. It's resolving dependencies. Yeah, now it's showing up as in bold. Okay. Yeah, here we go. It's a hell of it's a good thing. I'm not even going to say it. Yeah, I'm going to say it. It's a good thing I'm not relying on it's a good thing. A lot of people have said along the way, why are you doing this in Java? And my response has been, I wanted to focus on learning the fundamentals of the engine and creating a 3D engine and Vulkan drivers and OpenGL and all that stuff. And I wanted to just utilize my already extensive knowledge of Java, right, to do it. Yes, I could have done it in C#, I could have done it in anything else. But if I had done that, I would have also been fighting not only trying to learn all the fundamentals of an engine, but I'd also have to be refreshing my knowledge or even learning straight up C and C# and all that stuff. Like I've used C in the past, but it was a long time ago, and I would still have to bring myself up to speed with like just basic compiler stuff and all that stuff. Here's a good example right here of like, I know the Maven build system, I know Java, and I immediately saw something was wrong here that didn't look right. And I was able to diagnose and just fix it, right, relatively quickly. That has nothing to do with the engine. It has nothing to do with learning anything. It has everything to do with your knowledge of what language you're writing in and the tools around that language, right? And that would be something that, had I been doing this in C# and there had been like an error like that, or I probably would have been sitting here spinning my wheels being like, why is this looking weird? Why is this not doing this? Why is it not doing that? You know what I mean? So there's a good example there, because the code from this book has been wildly inconsistent as far as quality. I mean, it does what it needs to do, and I am learning some things, hopefully, but it's still there's little things, like little gotchas like that I would have been spinning my wheels on for a while. Anyway, rant over. Chapter 19, my friends, is indirect drawing. Until this chapter, we have rendered the models by submitting one draw command for each of the meshes as they are composed. In this chapter, we'll start our way to a more efficient way of rendering. I like efficiency. This type of rendering does not receive a bunch of draw commands to draw a scene. Instead, they relay. I think he means they rely on indirect drawing commands. Indirect draw commands are, in essence, draw commands stored in a buffer that obtain the parameters required to perform the operation from a set of global buffers. This is a more efficient way of drawing because we need just to record a single draw call. We can perform in-GPU operations such as culling that will operate over the buffer that stores the drawing parameters through compute shaders, reducing the load on the CPU side. It's becoming more and more obvious why games have thousands of shaders now, because I was always wondering, like, when you occasionally start up a game and Oh god, the latest Dragon Age was the worst with this. Like occasionally you'd start up the game and it would just sit there for like 5 minutes recompiling shaders, and it had like something like 12,000 shaders or something in it. And I kept asking myself, why the hell are there so many shaders? And now I'm starting to understand that the shaders aren't just visuals. They're also doing probably a lot of these compute shaders. Probably a lot of them around, I imagine, things like physics and whatnot, where they're taking the load off the CPU by shoving all that calculations down to the GPU, which, generally speaking, is probably a good idea because the GPU is ironically better at math in general. I guess it's not so ironic because that's basically graphics, right? Is just math. That's geometry is basically math. And better at that. It's more purposed for that. And so you take that load, take that burden off the CPU and you put it on there. Though I wonder, I guess then at that point you're just using the CPU for just game logic, or some of the game logic anyway. That's kind of the interesting thing. I wonder where the point of diminishing returns hits. Like, how many things do you end up doing on the GPU before you start creating performance problems in the GPU itself, rather than on, how many of those could you pull back out onto the CPU and put into different threads and have those threads going? I guess that's the kind of the interesting question there that I assume we'll eventually come to. And hopefully I can find an answer to that. Because I have no idea. The only way I'm going to know is by shoving 3,000 pounds of shit onto the GPU and hoping I don't melt it in the process. I gotta use this computer for regular streams and gaming, so I can't destroy the hardware. Okay. The ultimate goal is to maximize utilization of the GPU while removing potential bottlenecks that may occur at the CPU side and latencies due to CPU and GPU communications. You'll find complete source code for this chapter here. As has been introduced, we'll use a buffer to store indirect drawing commands to render a scene with a single draw call. Basically, we will store in a buffer vkdraw indirect command structures, which will contain information that will allow us to refer to the different buffers that will hold vertex information, indices, materials, and per instance data, such as model matrices, etc. The draw indirect command is defined by the following fields: vertex count, number of vertices to be drawn, instance count, number of instances to be drawn. If we have several entities that share the same model, we do not need to record an individual draw call for each of the entity and all the associated meshes. We can just use one command to draw a mesh for all the associated entities. We just need to set up a number of entities with this field. Okay. First vertex, the index of the first vertex to be drawn. First instance, it can be used to set up a unique instance identifier to be used when drawing. We will see in the shaders how we can use it. It is important to note that we will not be recording calls to draw indirect commands. Is that what we just said we were doing? Oh. We will not be recording them. We will not be start recording, basically. Instead, we'll store them in a buffer and trigger the drawing by performing a single call to draw indirect function. This requires us to restructure the code and use additional buffers to properly refer to the data we will need. In order to understand how we'll use indirect commands, let's imagine we have the following structure. To simplify, we will not use animated models. Okay. Entity A, Entity B, Model 1, Mesh 1, Mesh 2, Material. Entity C, Model 2, Mesh 3, 4, Material 2. We'll have 3 entities. The first 2 share the same model, which has 2 meshes, while a third one has a model which is not shared by another entity and has 2 meshes. We need to record the following indirect commands. Indirect command 1, vertex count, mesh 1, vertex count. Okay. Instance count 2, because there's 2 entities. Okay. First vertex, first instance. Command 2, mesh 2, vertex count 2, and first instance 2. I see. First instance, that's because that's entity. Wait, shouldn't that be at 3? Yeah. 2. Instance count, first instance. Instance count 1. Instance count 2. Huh? Oh, wait. Mesh 1 and Mesh 2. Instance count 2. That's... That's really confusing. They made a diagram and they made it more confusing by having a diagram. Mesh 2 vertex count. Instance count 2. So that would be this whole instance, and then put instance count 1 for 3 and 4. What's instance count? Number of instances to be drawn. Okay. First vertex is the index of the first vertex to be drawn. First instance is to set up a unique instance identifier. Okay. So that's just a unique identifier. I don't know why it goes from 0 to 2 and then 3 and then 4, but that's... Apparently that makes sense to somebody. First vertex is 0 on all of them, though. Index of the first vertex to be... Okay. Vertex count. With animated models, it's not so simple to use instance render, since the entities, even if they share the same model, can be in a different animation state, and therefore we'll use specific vertex buffers that will hold the result of the animation. We will create a buffer that will contain as many entries as entities and will hold the model matrices associated to each entity. In addition, in order to properly address or access the entity and per mesh data, we will create a specific buffer that will have as many entries as the number of entities multiplied by the number of meshes associated to them. Each entry in that buffer will contain an index in the buffer that holds the model matrices associated to the entity. The material index. In previous chapters, we record a draw call for each mesh and entity. We use push constants for that. Now we cannot use this approach since we will submit a single draw call. The address of the vertex buffer, the address of the index buffer. Materials buffer 2, 3, entity B, mesh. Well, matrix entity. We need to enable 2 features in the device class. Multi-draw indirect, since we're using draw indirect capability. Draw indirect first instance. When using draw indirect, we need to set up a proper instance ID for each of the involved draw calls. We will do it through the first instance attribute of the VK draw indirect command structure. We need to enable this for this to work. Okay. We need to organize our entities by the models to which they are associated. So we'll create a map which will store per model identifier a list of entities associated to that model. Therefore, we need to modify the scene. Okay. Change provokes. This change provokes that we need to update the animations cache class since we need to traverse through the entities in a different way. Yeah. Create a class called global buffers that will hold. That's how they spelled it. Some of the buffers described in the introduction, and which starts like this. Okay. Buffers that we will use are buffer indirect withdrawal commands, buffer instance data for model matrices. You may have noticed that we use an array of buffers. We'll have separate buffer instances per frame in flight. We can then update the contents of the buffers associated to the current frame, while the ones associated to the previous frame, which may still be in use, can be safely accessed by the GPU. We will be upsizing the buffers as long as we run if need more space. We will never shrink the buffers if the data to be used requires less space to avoid buffer recreation calls. This is why we need to keep track of the number of indirect command buffers to be submitted, which is stored per frame in flight in the draw counts array. So we cannot use the size of the... Maybe higher than the actual number of commands to be drawn. Oh, man. They need to go back over all the writing in this chapter and, like, make it not sound like it's frame of consciousness. like use your words, use your vocabulary. Like, just stop. Like, it's rambling and it's hard to follow. Global buffers. Populate the buffers. Oh, is this? Are we getting Assassin's Creed here? Oh, I'm in the thing. Oh no, Aquaria. Okay. For a little bit there, it sounded like Assassin's Creed for a moment. The meshes associated to the model. Indirect command. Yeah, I get the feeling like this will make probably a little bit more sense as I write the code, because this is... I get the general gist of what they're trying to do, but I have a feeling they've gone to plaid as far as the structure of the changes. But let's see. Let's go. Let's just jump into it. Let's go here. We want chapter 18 and chapter 19 differences. Okay. So there's a few shader changes, which makes sense. It's actually not as many as I thought in the fragment shader, but the vertex shader definitely has more, and so does the shadow vertex shader. Okay. Right, nothing there. Animations cache, yeah, pretty much. Yeah, that's gonna change. I don't know. It looks pretty subtle as to what has changed here, but take a look at it. And then global buffers is brand new. We'll probably do that first because that's, I imagine everything's gonna key off of it. It's brand new. Render just brings up the global buffers. Okay, that makes sense. Animation render. Yeah, the changes are getting real subtle here, so it's going to be. They're doing command. Wait a second. Wait a second. 18 to 19. Command dispatch. Oh, this is the animation render. That's right. Command dispatch was always the thing there. Okay. You're right. It's like, I don't remember putting command dispatch there, but that's the animation render. A lot of stuff just did they get rid of? They got rid of render entities altogether. That makes sense. That makes sense. And the push constants got a little bit bigger. Okay. Honestly, I'm kind of glad they got rid of render entities because that's a mess. But shadow. Yeah. More code going away. Device is also. Yeah, we'll do the things in device because that's pretty straightforward. Just adding those two features, enabling those two features. Scene entities is now a map. A map of lists. Okay. And then that's it. Like, there's not. I mean, despite there being a giant new class, there's not a whole lot. There's a lot of removal of stuff, but not a whole lot of tweaking, which is kind of nice. Yeah, okay. So I have that. Yeah, so let's do the changes to device first. So we'll bring that up. That's after depth clamp. Okay. So we have depth clamp. And then features multi draw indirect is true. And features, whoops. I know they don't, doesn't matter what order they're in, but I'm just going to put them in the order they have them. Draw indirect. First instance is true. Alright, so that's the changes for that. And then we've got global buffers. Okay, let's see. Let's close that up for a second. And you know, I'm just going to create, just for the sake of argument, let's create a package. I'm just going to call it buffer. And we'll do new Google buffers. There we go. All right, we just got to run through that. I need to take a quick bio break, my friends. I will be all right back. Enjoy the music, please. Okay, I am back. All right, let's jump in here. I'm gonna private static final logger just in case here. Okay, so public static final int indirect command stride ek draw indirect command size of. Okay. Static final int instance data size is constants int size times 2 plus pointer size times 2. Final Vulkan buffer. Doing arrays for everything. Are they yeah. I'm pushing them out to like the max in flight, right? And I bet they have to be that size. Because it's mapping them all into directly into memory for each frame. See something here. Buffer. Yeah, see if they don't do it that way, everything's going to expect, because you're passing what frame in to everything. So everything's going to current frame. So everything's going to expect that to exist. It's gonna. All right, fine. All right, fine. We'll do a freaking array. Do a freaking array, I guess. Everything's going to expect it a certain way. Buffer, private final, instance data buffer. Matrix is buffer. Okay. Alright. But I'm going to just set them here. Go. Okay. Sorry about that. Alright, so that eliminates the need for a constructor. But now, let's see. Public void cleanup. Logical device probably. Oh, you know what? We'll definitely need the because we're doing a buffer, so it'll be allocation tilt as well. So arrays as lists, indirect draw commands, buffer for each. Cleanup device. Allocation tilt. 1, 2, 3. So indirect draw commands, model, matrices, buffer, and then instance data buffer. I don't know why they did it in that order, but okay. Just maintain it. Alright. Private void create or updates buffers. And then we're doing int frame number direct commands int number instance data number of entities. Okay, if oh, I see what they're doing. Okay. Indirect draw commands buffer frame is not equal null, and draw counts frame is less than number of indirect commands. Draw commands buffer frame cleanup. Right, it's true. Yeah. So if indirect draw commands buffer frame is null or create, it's true. Commands buffer frame equals new Vulkan buffer. Okay. Device allocation. Size is long. Indirect command stride times number of indirect commands. VK 13 VK buffer usage indirect buffer bits stored with buffer usage storage buffer bit or VMA memory usage auto for device. I'm guessing is what that is. Yep. VMA allocation create host access sequential write bit. Okay, 13 VK memory property hosts is bit. Okay. All counts for that frame is number of indirect commands. Buffer size. Number of instance data points times instance data size. Okay. So the only time, so I see what they're doing. The only time they're creating, or the only time they're recreating the buffer, is if the incoming size is if the existing buffer's size, or if the existing buffer either doesn't exist or its size is less than that of the amount getting shoved in for the next frame, for this current frame. Okay. So I see what they're doing there. Honestly, oh, this one takes into account draw counts too. Okay. Like some of this could be, I feel like almost generified, but it's fine for right now. It's fine for our purposes. If it's data buffer frame not null, and this data buffer frame gets requested size is less than buffer size, and instance data buffer frame cleanup create equals true. If instance data buffer frame equals null or create is true. Instance data buffer frame equals new buffer buffer size 13 VK buffer usage shader device address bits memory usage auto per device. In case you create hosts, access sequential write bit. Memory property host visible bit. Okay. Is false. Buffer size is number of entities times multi constants matrix 4x4 size. If model matrices buffer frame not equal null and buffer frame get requested size is the buffer size. Cleanup. Create is true. And then if model matrix buffer frame equals null or create is buffer frame equals new. Bucket buffer device that's buffer size TDK buffer usage shader device address bits and memory usage auto per device. Okay, oh, nope. DMA allocation create hosts access sequential write bits. Property host visible bits. And then that method's done. Yeah, duplicate code fragment. I'm aware. Get address. Okay. Get instance data address, hopefully. Instance data address. Frame. Turn instance data buffer. Cart frame. Get address. Public long get model matrices address. Address, there we go. Get draw count. And then get public Vulkan buffer get indirect buffer current frame, return indirect. It's instance data. Indirect draw commands buffer current frame. Alright, and then void updates. Device, issue spoken scene. Did I make animation cache? I think material cache. Yeah, just do frame. Try var stack is very stack. That's stack push. Map string lists entity. Entities map. Scene get entities. And make a map out of it. There we go. Var indirect and lists. New array lists. Draw indirect. You know what? I don't. Just do it here. And lists. There we go. And this entity index. Do we really? What are they doing here? What are they doing here? First index, base entity index. Instance data. Okay, yeah, I see what they're doing. Alright. Base entity index 0 or instance data string key and entities map key sets. What are they doing with entities? Just getting the size. Is that it? Is that all they're doing with entities? Okay. Choose entities. Get I J. What? Again, it's like they swap between C style and Java style constantly. And it just annoys the shit out of me. It's like you're not even using J. And I could just be the new for loop. What's even this inner? Oh, well, J is just, okay. J is just a throwaway to pull the entity, to just do to replicate the command for the meshes. So they're doing multiple commands for each entity. I see what they're doing. I'm not a fan of how they did this, but I see what they're doing. Because the other thing is, like, see, the problem when you're doing something like this is that you organize your code wrong. So, for instance, this guy, he's going to constantly be getting the same index over and over and over again, number of entities time, when really you could just move that up here where it makes more sense because it's only based on I, and then you do it once, and then he does it just to grab the number of indices off of it, which is, that's what it is. Like, I would, yeah, I mean, I would go, there's so many bad practice things that I see in here. And I don't know if the person who made this code up is a professional or if they're just kind of, if Java's new to them. I mean, I don't think Java's new to them because they're using stuff that even I don't use yet, like var and stuff like that. But it feels to me like whatever they do for a day job, they must work alone, or at least they haven't read a whole lot of code. Maybe they're early in their career or something, because this shit will drive you insane if you read enough code after a while, right? Because if you're trying to do code reviews or something, like, you know, first of all, you're re-grabbing this thing over and over and over and over and over and over again without any reason to do so. But on top of that, the only usage of Vulkan Mesh here is to get the number of indices out. That's it. So you're bringing in this whole big object, or you're not bringing in, you're making this whole big object available to this loop, and all you really need is just one count off of it, right? So really this should just be Vulkan Mesh list, get I, and then number of indices, put that into an integer, and just use that. Alright? It's like, I would understand this if they were actually checking to see that this isn't null. They don't even give a damn if it's null. If it's null, this whole thing just craps out, which honestly, sometimes you just want it to crap out. You know? And this is one of those situations where, yeah, I totally not check that for null. But it just annoys me because I see a lot of this in this code, and it just feels like the person that wrote this code either was going really fast and not really thinking, or they're just not accustomed to reading other people's code or being part of a team where people have to read their code. Because I guarantee if you're part of a team and you're doing this kind of thing, somebody at some point is going to yell at you. Usually after they were up at 2 a.m. trying to debug a problem, and you had them chasing ghosts all over the system, because you were pulling in more shit than you needed to pull in. I may or may not have yelled at somebody for that at some point in the past. All right. So we got entities map. Entities, is entities used by anything other than just to get the size? It's just used to get the size. Do I even need the size? Yeah, I need it for this. Okay, that's fine. So let's just do int number of entities is honestly, let me think here. Does it buy me anything if I did entry set instead of key set? Because it'll just give me an entry set with the key and the value. I mean, the only thing that buys me is... Yeah, that would buy me. I mean, that technically buys you performance, because you're not then doing another lookup in the hash map for that key. Yeah, you know what, let's do entry set here. Let me just let the IDE fix it. There we go. That works. Nice. So then I can just do number of entities is entry value on get value size. There we go. And I'm getting the model from the cache. For what purpose? To get the lists of meshes. Oh, we need the model to know if it has animations. If model has animations, otherwise do something else. Okay. Alright, so open model. Now the models cache, did I make that? Yes, I did. So model cache, get model, or entry get key. There we go. And then number of meshes is the mesh list size. So number of, why do I need the number of meshes? I don't need the number of meshes. They're just being dumb. Okay. So we're going to do if model has animations, I'm going to do model. Are we going to be manipulating things outside of here? Yeah, probably putting stuff in the command list. So I'm going to do a for each here. For each var mesh in model that get mesh lists. Go. And now we're saying for int I equals 0, I is less than number of entities, I plus plus. Before we do that though, we're going to do, well, I have the mesh already because I did it the right way. So yeah, I did it the right way, so I already have the mesh. What's going on here? Semicolon expected. Oh. There we go. Whoops. So our command CK draw indirect command stack vertex count is well, in this case, since I have mesh in the correct spot, I'll just do mesh to number of indices because it's part of the for loop. So instance one, first vertex is 0. Oh, excuse me. Oh. First instance is base entity index. Cool. And then, oops, that's semicolon there. And then command list dot add and base entity index plus plus number of instance data. Where the hell is that being used? Oh, I guess, oh, that's a general counter for down there. Okay, yeah, right. Instance data plus plus. Alright, and then if model has animations, we do else here. And we're looping over the... Where did you get the number of meshes from? Oh, well, I'm just doing it the model gets, yeah. I'll do it the same way. So for var mesh in model that gets mesh list. Okay. Our command is ek draw indirect command stack vertex index count is dash dot or indices. Instance count is number of entities. First vertex is 0. First instance is base entity index. Okay, command list add. Oops. That's not it. And command. And base entity index plus equals number of entities. I wonder why that's different. I just did plus plus up here, right? Huh. Oh, I guess because they're trying really hard to make it a unique index. Which there's better ways to do it than that, but I'll have to see how that's being used, because yeah. Number of instance data, number of entities. Okay. So then total entities. Okay, number of entities. That's a new, okay. Oh, man. Sneezing like crazy here. All right. Here. I think I might want to transition to standing up, though, because my legs are bothering me here. But let's do this real fast. Update buffers. Frame. List size. Instance data. Total entities. Update. Direct commands. Frame. And update instance data. These map and frame. Okay. I'm gonna mute the microphone for a second while I get the standing desk up here, and I'll probably turn the webcam off because you won't be able to see all of my face, but it's loud, so let me mute this for a second. That's better, but I think I have to sneeze again. 1 second, let me turn webcam off. It's not showing much here. Let me grab the pad to stand on. All right. Got a nice soft pad to stand on instead of the hardwood floor. Get my headphones back on. Okay. We're in business. Yeah, my bad leg is annoying me, so I'm hoping by standing up for a little bit it'll help ease it. Okay. So we got the indirect commands. Okay. Private void. A little bit here. Private void. Update indirect commands. Nice. Util. List. PK. Draw indirect commands. List and frame. Okay. Let's do a number of commands. And buffer put. I see what they're doing there. Okay. Number of commands is list size. Buffer is indirect row commands buffer for that frame. Byte buffer. Data buffer. Util. Byte buffer. Buffer.map device allocation util int buffer get requested size. One second here. My compression sock is really digging into my leg here. Wow. My leg is so swollen that it actually caused my compression sock, the top of my compression sock, to slide down and just be like almost like a tourniquet on my leg there. I moved it around a little bit so it's a little bit better here. Oh. It's crazy how this stuff works, because it's like compression socks are helping, but there comes a point where it's like they end up pushing all the swelling up my leg further, and then that causes the compression sock to slide down and not be able to have it pulled all the way up. Anyway, I like almost to the point of just taking it off and saying, oh well, it'll just be what it'll be right now. Okay. So what do we got? Data buffer. Okay, draw direct command buffer. Okay. Draw indirect command buffer. Data buffer. Commands I plus plus. Command buffer put I. And list get I. For unmap. And there we have it. And then update instance data. Do map string lists entity entities map, and then frame. For now, we'll do it that way. So buffer instance buffer instance data buffer come on frame go on mapped memory is instance buffer map byte buffer instance data is retail byte buffer mapped memory int instance buffer requested size model buffer is matrix buffer frame mapped memory is model buffer map byte buffer sees data is memory util byte buffer mapped memory buffer get swoop requested size okay. Base MD 0, offset 0. ID. In the entities map key set, get model ID. Just need both. So we'll say correct entity. Well, we'll find out. Map entry set. Entities equals entry. Come on. Value. And model ID is entry dot key. Okay. Number of entities J entity base entities plus J. Okay, so we're using it for multiple things there. Hey, Tech, welcome on in. Few days and my week off work, and I have to go back. Yeah, I get it. Yeah, it's my last day off too. I go back to work on Monday. Although all that really means is I have to log in, and generally look presentable from the waist up anyway. But other than that, but yeah, and I'm walking back into a just a big project going on. It's been going on for a couple weeks now, and it's not to complain too loudly, but we have a good problem and a bad problem. The good problem is our system has grown to a point where it's ginormous and it has a lot of features, and it, we can demand a lot of money from customers. The bad news of that is it's ginormous and it has tons of features, and every time now we want to do something new, it's like there's no small changes anymore. It's all just like huge undertakings, because you got to fit it into the larger picture, and it's got to, it's not just a feature that sits on its own. It's got to integrate with the other features in the system, and testing all that, and making sure that it's robust and everything. I mean, we're thankfully, knock on wood, we're kind of kicking butt on that, where it's like, so far we haven't had any like major snafus or flaws that have made it out to the customers, but we've got almost 1 million lines of code, and it's like we got almost 1 million lines of code and no automated testing. So there's just 4 of us plus 2 testers, and it's just like it's a thing. It's a real thing. It's nerve-wracking sometimes. Be in your underwear and a nice shirt at your PC. Exactly. I mean, that's generally all you need to do when you're working remotely. Exactly. And obviously occasionally shave. I mean, I guess technically I could let my beard grow out, I guess, but I don't think that would look good with a with a big beard. Yeah, drive 45 minutes to work and bust your butt for 12 hours. Yeah, no, I get it. And hey, you know, it's not like I completely avoided that my entire career. I mean, first job I worked at for, well, actually it's really the second job, but the first job in my programming career I worked at was an hour and 10 minutes away with tons of rush hour traffic one way, so I get it. Trust me. I can get away not shaving. But if I shaved, they all wouldn't know who I was. Yeah. Yeah. That's also a funny thing to think too, is that like even though I don't have I only have a small goatee, which isn't much of anything. Pretty much most of my colleagues have never, actually all of my colleagues have never seen me without it. So that would be kind of a shock to their system. I started pretty early on in my career to try some kind of facial hair. I tried just a mustache and it didn't work out. It doesn't get bushy enough. My brother can rock a mustache. I can't. It just doesn't, it's too patchy. You know what I mean? Which is why I went with something a little bit more that doesn't require a whole lot of maintenance. Like all I have to do is occasionally, you know, trim it just a little bit. I don't need to buy any products for it or anything else. I can just kind of deal with it. And you know, also like it doesn't really cause me to sweat too much either. Trick, easy way it disappears is shave once. No one has seen me without it. Not even your wife. Oh, there you go. You got your alternate identity all ready to go. It just requires a straight razor and a bug out bag. Yeah, shave, change my clothes where I know what I'm doing. There you go. I mean, there's an advantage to that. If you really need to get away from it all. Alright. So what? So we do a number of entities. So we do need the number of entities here. I spelled it right the first time. There you go. There you go. Nice shirt, nice pants, nice shoes, nice shave, and goodbye. Yep. Yeah, I get it. I get it. Oh, man. So what is this? Entities, entity size, number of entities. Okay, so they're doing, grabbing the model. They're seeing if it's an animated model. Okay, so grab the model cache here. model hash get model ID. And then frick me, this number of meshes, are they using this for anything other than the loop? No. So what are they doing? They're grabbing a list. They're doing a get I on it. Vulkan mesh list. Wait, why are they doing it? Oh. Wait, what? Why are they grabbing it twice? They already have it here. I swear to God, man. Yeah, that's so stupid. See, this is why you do it right. This is why you do your freaking loops correctly in the first place. So you don't retrieve something and give it a different freaking name. Anyway, so vertex buffer address, index buffer address. So we're looping over the meshes, and then we're looping over, and then we're doing to number of entities like we did before. Okay. Alright, so we're gonna do the regular for each. So for each var mesh in model get mesh lists. Alright. Takes care of a little bit of that. So long vertex buffer address is mesh vertex buffer get address. There we go. And index buffer address is mesh index buffer get address, and then for int I is 0, I is less than number of entities, I is plus by entity equals entities that get I. T index base entities plus I model matrix get any index times Vulkan constants matrix 4x4 size, put it into matrices data. Alright, and then instance data, put int offset ft index, and offset plus equals Vulkan constants int size. Right, and then yeah, it's doing mesh list get I, not J. So it is still the same freaking thing. Alright. So we're doing instance, that's what the hell? Instance data, put int offset. Now we're doing material cache here. Now, did I set material cache to have a singleton? I did. Good. Good, good, good. So, material cache, get position, mesh, material ID. Alright, offset plus equals constants in size. If animate, oop, I didn't do that, did I? Animate model. Where did they pull that off at? Wait, is that the only place that they're doing animate model? Oh, for crying out loud. Just sure. Alright, so model has animations. Vertex buffer address equals animations cache. Now this one I'm pretty sure I did the instance on. Animation cache is animation cache instance. No? So this is animation cache, get buffer, entity, get ID, mesh.id, get address. Okay. And instance data, put long offset vertex buffer address, offset plus equals instance pointer size. It's data, put long offset index buffer address, offset size. Okay, and then this is for int I number of meshes, and this is mesh list. Okay. Base entities plus equals number of entities. Okay, and then instance buffer unmap and model buffer unmap. Okay. That's the end of that class. So did we use everything in here correctly? That was a lot of stuff, but I feel like, well, the only way we're going to know if I screwed something up is if it just doesn't work at this point, because there's just too much to go over in there. But I feel like the vertex buffer address. Oh yeah, okay. It just, okay, we just change it if it's an animation. Got it. Okay, that kind of threw me off for a second. All right. So that's global buffers. That's the brand new class. I have errors in this class. Let's. Oh, you're right, because I don't have that thing in scene yet, and I don't have the get entities has to change, so we need scene changes. That's fine. Okay. We'll get there. Okay, animations cache. Render we saved to the end. Near the end. Animations cache. I guess we could try and tackle this. If I can figure out what actually changed here, because it's very subtle, it looks like. It looks like maybe some flags? No? Maybe? Let's see. Animations cache. Let's pull that up in their code. Chapter 18 there. So load animations, what line? The whole thing is highlighted, huh? Great. So var lists. I mean, right away it's different because we're doing a number. Oh, they switched over to the for each loop. Is that all they? No, look at size. Oh, okay. It looks like the whole method is at least a little bit different. All right, let's do animation cache. So load animations, entities, entities size. So they have a number of entities. Wait, is this the right one? Chapter 18. No, this is not the right one. I need chapter 19. There. This, I use chapter 19 over here, right? Yeah, 19, 19, 19. Okay, just making sure. Did these buffers change at all? Map string. Welcome buffer. No, those look the same. Alright, the animations. What do we got here? Var list. Oh, I see, because it's map string list entity now. Okay, that does change things a bit. Entity. Entities. So let's do a list entities values. So I need, it's isn't it for each gives me what? Yeah, KV, right? So it's key value. List entity, string key, list entity. Yeah, there it is. Okay, that showed up properly. So this is, and we don't necessarily care about the keys right now. We care about the values. Right. But I need frackety frack. I need the, god damn it. Yeah, we need a second loop, so that's why it looks so crazy. Size used for anything else here? No, it's not. It's just used as an iterator. Okay. So we're just going to do... do entity. Oh, it's v dot for each. No. Yeah. Man, all this shit's got to go in there now, right? Looks like it. Let's just stuff all of this. Include the if there. Up into here. There we go. Okay, so now we're looping back over entities again. Size entity, let's get Vulkan model. Model cache, get model, entity model ID. If model is null, throw a runtime exception. Okay. If it doesn't have animation, right, okay. It just yeah. So I swapped that around and said if it has an animation, do this stuff. Rather than just doing that. So if the model is null, new runtime exception. Model or entity ID empty. Wait, model ID is string, right? String. Sent S not found. Formatted e.get model ID. Go. Okay, and then buffer list is a map. Vulkan buffer map. Put that there. Vulkan mesh lists, mesh animation buffer. Oh, for mesh lists, number of meshes, mesh list. Okay, so that's same thing. Animation buffer, Vulkan buffer, vertex buffer, get requested size, buffer usage, vertex buffer bit ORed with storage bit, ORed with device address bits, VMA, memory usage auto. Oh, and then VMA flags is 0 now. So it actually swapped back to 0. We changed this in the last thing to that. Okay. It's back to 0 again. Red flags 0. Buffer map puts that. Okay. And then no other changes. So what did we actually change here? Oh, well, we changed it. It has to take this. So we changed it just to accommodate that. And also added the runtime exception. Okay, fair enough. Alright, what else? So render we're going to hold on to. And animation rendered. Is this the same change then? Is to take the list of entities, map values. Yeah, it looks like it. It looks like it's just the same thing because it's got a loop over that. It's got an extra loop that has to do. Okay. Animation render. Chapter 19. Where is this at? It's under render after scene. Alright, here it is. Entities map. Alright. Animation renderer. So we're taking... Wait, what? Oh, yeah, okay, right, to do it. And he's okay. So... So this is where they were grabbing just the entities that have animations. And I did an extra loop here to grab that so that I don't have to deal with it down here. Unfortunately, that means I need to do... Get entities. Before we do this, you know, this is one of those things where I feel like I should just, we have a get entities, right? Like, why don't we have a get animated entities and just push that shit up into there? Like, it makes life so much easier. Because they've changed get entities to be a map string list entity. And this has to get set now properly. Oh, well, no, it doesn't. It's just new hash map. That's right. So entities, so add entity changes. We've actually used some good things here on this. So doing, yeah, they've actually done it smartly here. So, var lists equals entity shoot if absent. Entity get model ID new array lists and then list that add entity. They did some good code there for change. actually look at that here. So, did they actually get rid of the remove all entities and stuff? No, they still have it. Remove all entities and remove entity. They actually fixed remove entity, but they still don't call it, which is pretty hilarious. I will fix it anyway, just because I have to. You know what? Actually, screw it. It's not even called. Screw that. I'm just getting rid of both of those. Hell with it. It's not even called here. It's grayed out. So it's, I don't know the whole point. Anyway, get entities. So we do have the get number of entities, but also let's do the get number of entities. So public int get number of entities. And that is return entities that, what the hell are you doing there? Values. Stream map to int list size. So, okay. I didn't even know sum was a thing on the stream. Yeah, some of the elements of the stream. Huh. Never had to actually do that. It's pretty nifty. Okay. Number of entities. And what else? Wasn't there a, where's the get entities just does that? Oh right, I wanted to add a public lists entity. Do I need the map? Is there a reason to have the frickin' map? When we add an entity, oh, it's just the model ID is there. Yeah, it's just the model ID that's there. Well, yeah. Yeah. I mean, I know everything that they have is structured around the map, probably. And yeah, because you don't want to just bring back, you want to bring back everything. You want to bring back the entire list of entities, not just, yeah. Okay. Let's do map string list entity get animated entities. Okay, so how are we going to play this? So I've got to do, well, I got to do the double loop, basically. Yeah. Yeah? Maybe? Well, let's see. Let's see what we can glean from here. If I do entities, entry set. I could do compute if present. Compute if present. No, I don't. Yes, I could do that. So if I do compute if present, it's on the key. Yeah, I can't do that for this one because it needs the key first off, which I don't have. I'm doing entities dot entry set dot stream. Would any match would probably work, right? Any match. Any match on, so it's entry string list. So any match on KV. And where, yeah, maybe. Would kind of work. So all I have to do is figure out this size here. So V is a list. So I have to say so return V or no yield V. It's not gonna work. Return V dot string. No. Oh, V dot get yield. V dot get. Why? Why are you being a pain in my butt here? V dot. What do I have access to? I don't have access to anything? What are you killing me here? V dot. What the hell? Match. Non-interfering stateless predicate to apply. Non-interfering stateless. Why can't I call any methods on it? where it's no, because V is a list, so V. Yeah, I have to loop over to V. Well, V stream any match. You're right, because it'll stream for everything. So it's any match would be entity. Something is, it doesn't like something here. What's going on? Resolve method V. If I do so. Java sub hash map based on criteria in value in subhash map based on a list of keys. That's not based on criterion of value. How to add class objects to a hash map based on values. What is the best way to get a subhash map based on a list of keys? That's that one. Submap for a hash map. Filter map by a list of keys. That's all like low-hanging fruit. I want the hard stuff here. Hash map with a list of keys. Submap based on a key. Yeah, that's not. Retain all. We can get the map's key set. Use retain all method to remove all entries whose key is not in key lists. That's like freaking low-hanging fruit there. A hash map where the key is a string and the value is an object of a custom class. Yeah, okay. Which is a price attribute. You want to create a sub hash map. Price created a certain amount. Okay. What are you doing? Product map, entry set, stream, filter. Entry. Well, that would make sense, yeah, because I do want to filter before I do. Okay. Entry, get price. And price thresholds. Oh, see, they're just doing entry that way. They're not doing a KV, which I was wondering if I could do. Yeah, that would make sense. You can do KV as well, and just do V dot whatever, but. Okay. the tricky part is that it's a list. A map of lists here. That's the only one down here. So yeah, I'm thinking too far ahead of myself is what I'm doing. Let's try that for a second. Let's do return entities, entry set stream, filter, entry, let's say, so go in here. And we'll say, entry, get value, any match of because that will return a boolean. Any match entry, no, entity, entity, get is not null and entity dot has why is it not showing? What are they? Wait, what are they doing here? Oh, has animations. They're doing two checks. They're doing model has animations and the entity has entity animation. Well, this is still useful in that capacity, so let's just do let's have the right thing here. Filter and then match entry what the hell would we do then? It just, oh yeah, collectors to map, right? I was like, I'm pretty sure I have to do like a collectors. Select. To map. And then how do you do this? This is always confusing me. Map entry, get key, map entry, get. Oh, well, yeah, I guess that makes sense. I think that return is not right. Statement lambda can be replaced with expression lambda. Alright, well, I'll try it. What did it do here? Oh, it just chained them along. I guess that makes sense. Okay. I don't mind that change that it made, although we have quite the run-on thing here. But, I mean, if it works, it works. And it looks like it'll work. It's just they chained everything along. Instead of having it in the middle, inside that, like that, it just did it this way. Which, given that return didn't look like it was working there, I think that other way probably wouldn't have worked. Not this way is going to work, but it looks promising. So that'll give me a sub map with all of the entities that have a entity animation that's not null. Still not and then we have to look at the model to see if the model has animations, but that doesn't change that much here, right? Well, it does, but it's... Get it for the model ID. Oh, we'll see where this puts me here. So... Yeah, let's see where that puts me. Let's see if this actually helps me or not, or just isn't worth the time I just spent on it. Either of those could be true. Alright, so trying to get the animated entries. What was I doing here? I was doing... Oh, I was only bringing back the models. Oh, yeah, no, I was doing entities that have a model. Oh, I can still kind of do this. Okay. Let's do it on the next line, though. So, I want to do var animated entities. Scene get animated entities, and then stream, no, not to stream, no, why, oh, because it's a map now. Entry set, stream, no, entry set, wait, well, is the model ID. Entity get model ID. So we entity get model, but the model ID is the keys. So I should be able to just do key set then, right? I'm going to go on the assumption. No, let's just do entry set. Hell of it. Entry set filter. Doing entry set, so Vulkan model equals model cache get model e.get value dot get now it's gotta go over. Damn you. Damn you to hell. Yeah, they're doing the actual entity model ID. Damn you to hell. How am I gonna do this? So I gotta filter. Entry set stream filter. Shit. Filter. So this has the loop. This has the loop some more. This would be this on a new line because this is getting crazy. Dot get value dot stream what are we doing there? We're just getting the model ID. Checking to see if the model for that model ID has an animation. Stream. God damn it. They would go and make a shitty data structure, wouldn't they? God damn it. I'm just gonna have to I'm gonna have to double loop this. Actually, they have a freaking triple loop, don't they? Because of course they do. Person that wrote this just, they love their freaking nested loops, man. They get off on them. All right. I gotta do it. I gotta do it the stupid ass way. Until I come up with a better way to map this. They should have just freaking map of a list. They should have just like made a freaking object. Anyway. So we need four more entity lists in get entities. I guess I could do get animated entities because, well, the hell with it. Get entities. Screw it. And when size is size used by anything other than to loop. It's used only to loop. Okay, so we're not doing size. So they want entity lists. So I just want to loop over the entities. Oh, and get entities dot value. Damn you, dot values. There we go. Yeah, they're like going over the values, right?
Damn good coffee.
I could have probably simplified that and just went over the values, but oh, whatever. We'll just do this. Spent more time on it now than it deserves. Var entity and entity lists. String. Model ID is entity. Model ID. Actually, you know what? This is this code here, right? So let's grab that up here. Okay, and this is just entity get model ID. Right, so model cache, entity, Vulkan animation. Although I have to do the check that they do. I'm getting all the entities here now. So I gotta say model here. So if model.get nope. Let's try it again. If entity.get entity animation equals null or not model has animations. Continue. Okay. Okay, otherwise we got animation model, get animation list, get any animation, current frame, get address, buffer. Okay, and then mesh lists, look over that. Set push constant. Oh wait, number of meshes. J. Number of meshes. Oh no, that's fine. Yeah, I think that's all the same. I think we're okay here. Push constants is all of that. This is entity. Get ID. Mesh get ID. Address. Size map. 1, 1. And this needs a thing there. Actually, that should be over 1 there, and then we need another closing full loop here. All right, and then I just get rid of that. And this for loop is done. Get rid of this altogether. And then we have the recording stop there. And I think the push constants change a little bit. I think. No, they didn't change it all. Okay. I think it was just the reading of that thing, which I spent way too much time on something that stupid when it's just going to be. I'm going to be moving things around into places where they make more sense to be. So doing that refactoring then was kind of silly on my part, but you know, it is what it is. I'm going to make similar changes to scene renderer and the shadow renderer because it's just doing that. And device, and then I've made the changes to scene. Although, did I make the change to the remove entity? Oh, well, they're not even calling remove entity, so I got rid of it. Yeah. So that scene is done, device is done. So I need to do the scene renderer and the shadow renderer. And then we got some shader stuff to change. All right. I'm going to have to stop there though, because I feel my brain starting to shut down a bit. Let me make a note for myself where we've left off. So I've done that. So render, we still need to do, so let's do this. First of all, we can run a branch so I can just commit So we're good there. Doesn't need to compile because we're on a branch. Chapter 19 in progress. All right, and we'll push those. Okay, so chapter 19 remaining items. So shaders, and then render Java and I just finished animation render, right? Yes. Okay. So scene render. Shadow render. I'm not even spelling correctly. That's how addled my brain is right now. All right, shadow render, and then device is done. Scene is done. All right, yeah, we don't have that much left. It's just what's there is a pain in the balls. It's really what it comes down to. And then just out of curiosity, I think chapter 20 is like even smaller amount because it's just we're just doing multi-threading, which we pretty much already have in place. It's just we'll have to get some executors going. Yeah, multi-thread. Yeah, it's actually they don't even have that much listed here. And I think if I do a comparison between chapter 19 and chapter 20 here. So there's nothing there. And then yeah, just engine. We fire up an executor in here, the fixed thread pool, jump into some futures, and wait on the future tasks. That's just basic. Update global buffers, yeah, it's just called from. Yeah, it's just basic multi-threading stuff. Nothing big there. And then in render, it looks like they get rid of the current frame. And they're grabbing it off of global buffers. Update. How are you doing an update to the current frame? Oh, no, they actually removed that. They removed any references to the current frame there. And then they have a new method, update global buffers, that takes the current frame in. Yeah, so that gets called from a different thread. Yeah, I mean that's like of all the things we've done, these are probably the simplest changes here. Just like two files, render and engine, and then we'll be done. So, or we'll be done with the book anyway. But still have plenty of things to do on top of that. Then it just comes down to going through. We'll do some refactoring. I'll try to figure out some better ways of looking at things. And then we have to come up with a list, probably tomorrow, come up with a list of first steps. There's a lot of first steps. Like I have to figure out the menuing. I need to fix the mouse, the control for the camera. We need to make it so that the keyboard controls don't send me into the stratosphere on the slightest touch. Gotta make it like go a little bit slower. I need a better way of loading models in. I also want to do, like, I want to take the models that we have loaded now, and I want to add a skybox, because we're going to need a skybox. Even in space, we'll need a skybox. And some kind of ground, just a flat ground, a flat textured ground, nothing too crazy. I eventually want to get way down the road into procedural generation, so we have like procedurally generated planet surfaces, which, I mean, probably won't go any further than just like some kind of noise, like mapping thing, like a Perlin noise or whatever they do nowadays. We'll have to look to see what the newest technique is for that stuff. But generally, my friends, let me we'll switch back over to the main branch, which is stable here, so we can take a look at it. But generally, my friends, we are here's where we're at. We've got audio playing, and we've got a character loading in with animation, just a looping animation. I can control the camera. We've got cascading shadows, though I still don't understand. I guess that's a model limitation. I don't understand why the lamp doesn't have a shadow, but his sword does. So something about that. And we can manipulate the, where the shadows are cast and all that stuff. So that's pretty cool. I got that at least working. And yeah, we'll just have to take it from there. Oh yeah, see how fast we go? That's why I'm losing sight of it. We're zooming around so fast. I removed that 1 second delay that I put in there, and it's now we're just like zooming off in no time flat. So I gotta I gotta link that to a timer or something. Anyway, my friends, we're gonna pick this up again tomorrow, and as usual, I'm probably gonna do a bunch off camera. I might even I'll likely finish this chapter before we get back together again. And probably finish chapter 22, because that, like I said, doesn't seem like there's much there. So we'll see. Assuming, of course, I didn't break something here, which, is my MO. So yeah, tomorrow night we'll pick up from there, and hopefully I'll have this plus chapter 20 done at that point, and we can start to come up with a list and start looking at additional topics for a change. So that'll be nice. And yeah, certainly have a lot there to look at too, and also try to tweak. I'll save some of the tweaking and the and obviously some of the refactoring for the stream and stuff. But I'll try to at least, and then we'll just see where we're at. So yeah, my friends, that will do it then for me for tonight. If you happen to run across this on the YouTubes and you have a like and or a subscribe that you can spare and maybe toss my way, that would be really awesome and swell. It helps out tremendously, and I appreciate it greatly, my friends. Perhaps 2026 will be the year that I hit 500 subs over on YouTube, and maybe potentially unlock the first stage of monetization over there. Don't know. It would be nice, but we got a ways to go as far as subscriber count goes. You have to get to 500 subscribers for that. And our watch time is doing well, so we're on the path to hit the correct amount of watch time this year. But we'll still be held back by the subscriber count. So that's a thing. But otherwise, yeah. Thank you so much, everyone, for watching. I hope everyone has an excellent morning, afternoon, or evening, depending on what it is for you. And hope to see you back here again in the future for some more stuff, whatever happens to suit your fancy. Until then, see you, bye.
I suppose by the transitive property, I too must be Vulcan as a motherfucker.